Hello everyone, my name is Matt Smith. I'm with Shunk. I've been with Shunk for 8 years. I'm part of the applications engineering team. If you have any questions about the presentation we're about to see, feel free to write in and ask any one of our team. Thank you for being with us today. I hope that you get something out of this. Today we'll be talking about robot accessories, specifically anything that's on the robot at the end of our tool. So behind me we have a FANUC robot, we have a tool changer on the robot, and we have multiple tools like this one you see down here that would attach to the robot. So today we're going to be focusing on this area of the robot and the tools that Shunk offers to our customers to help build out your robot. So over on the table beside me, we have 3 displays that we'll be talking about today. We'll talk about tool changing, compensation, we have collision sensors that we'll be talking about as well. Specifically to start with, we're going to talk about the tool changing systems. On this display, we have an automatic tool changer that would automatically connect and disconnect and park the tool in a tool hanger. We have manual tool changers that you would actually manually disconnect. And we also have another automatic pallet changing system that's used for palletized handling, but can also be used in some cases for just general tool changing. We'll talk about the benefits of all in just a second. So in general, we'll talk about the automatic tool changer first. What you see here is the master side is on the bottom. And if you recall on the robot, the master side is on the robot. So this is upside down compared to what we've seen before. The master side tool changer has the locking mechanism, lock and lock-on sensors. It has the lock and unlock air control right here. And there's a module that allows you to pass electric signal through the tool changer when you are connected. This one also has an adapter plate with a gripper, and you can see that we can open and close the gripper with the tool changer attached. Now we can unlock the tool changer like this, and now we can change from one tool to another. Because this is an automatic tool changer, normally this would be hung in a rack first, and the robot would go to pick up the second tool. In this case, I'm holding it by hand. Some things to point out on this is you see the locking mechanism right here. You can see the balls that expand and engage into the race underneath. You also see the pins and sockets that would be used for electrical signal. In this case, we're passing through just simple digital I/O for the sensors on the gripper. To reconnect, we would simply align these pins. Of course, this would be done automatically. Unlock. And then lock it back in place. And this is how the system would work. So you would normally have 2 or 3 or more of these tool side tool changers. You'd have one master side tool changer that you'd be using. Now, some unique things about this tool changer is that on the tool side, we have a special module that has a window. And this allows you to note it, or you can control or recognize which tool you're picking up. Tool ID allows you to set this from 1 to 10, and you can be able to recognize which tool you have. So you can set this manually. That way, when you connect to it, you know which one you're connecting to. Other modules that are available, as you see, we have electric modules on here. We have another flat on this side that other modules could be mounted to. This is self-sealing ports. We also have different types of digital I/O connection that can be installed. And we can also do more complex things like communications, Ethernet, Profinet, digital or more digital I/O. We can do also motor control through this as well. So moving to the manual tool changer. On this tool changer, we've got an electric gripper, and you can see that we can open and close this electric gripper through the tool changer. So we have an EGP40. We have a compliance device on here that allows us to have a little bit of compliance if there's misalignment between the robot and the part. And then we have the tool changer. So in this case, to disconnect the tool changer, you would simply open this lever and you can take it off. This type of tool changer is excellent for universities, for applications where you might need to change your tool maybe once per day or once per week, infrequently, but you can see how this mechanism works. We have the air feed through ports under here. We have the electric connection through here. And then down inside here, you can see the mechanism and how this locks and unlocks the tool changer manually. Air passes through here, electric signal through there. So we realign, lock this into place, and then we can go back to work with the gripper open and closed. The third type we have mentioned is the VeroS NSR. This is intended to be a pallet changing system where you would have a robot that would feed a pallet into a CNC machine for a machining operation and then retrieve it and replace it with another. However, we do have additional feed through on this that allows you to pass signal and air through it as well. So this has a different locking mechanism. So if the other ones had balls or it had a shaft, in this case we have a mushroom head with pins inside that lock this mushroom head down. Again, you can see the air feed through, the electric feed through, same principle where you have a robot that has a choice of multiple tools that it can choose from to do whatever job it needs to. So when we lock this back in, we can see that the gripper now operates normally. And you can see the sensor lights light up. So we're passing through electrical signal as well. If you have any questions about this, I'd be glad to answer those later. Moving on to the next display. This display talks about compensation. So this would be an application, or it would be a problem where you have a misalignment between the robot location and the actual part location. So we have a variety of different kinds to choose from. We'll start with this device right here, which is our AGE-XYZ. And this allows us to allow the end of arm tool to float. So if we unlock this, you can see that we have compliance in X and in Y and in Z. Z has air pressure on it right now, so I can't collapse that, but it would normally. So when the gripper goes to grip something, this will allow some compliance to prevent binding between the robot and the grip point. Once you've picked the part up, then you can lock this back into place and it centers up. I'll do that again so you can watch it. Unlock, allows it to float, lock, locks it back to center. Now this tool changer also, or this compliance device also has another feature on it called offset position storage. This allows you to lock it in place so that now it won't move. It will stay in that offset position so the robot can go do a function and then come back to the exact same position that it was before. You can unlock that. It allows it to float again and then lock it into the center position and go back to work. So this is our large compensation device for large robots. It's available in 4 sizes. It uses guided linear rails for compensation, and it has air cylinders inside for locking. Moving on to the next type of compensation, we have our TCU. This is a small device right here, which is effectively 2 metal plates with rubber bushings in between. These bushings allow for a little bit of compliance that allow the unit to operate and not bind. This would be useful in applications where you're handing a part off from the robot gripper to a chuck, where there could be binding when one is gripping and before the other released. This one allows for a little bit of compliance. The third type is our AGE-XY. This unit offers the X and Y compliance just like the AGE-S, but also offers some compliance in about the Z axis. So for applications where you may need to have this twist, this might be a good selection for you. When locking, it will lock it back to center. We can unlock, and this also has position storage, so I can't move it when it's in that offset position storage. I can unlock that and then relock to center, and we're back to the center position. Now, this one also has, or this display also has a Z-axis compensation. This allows you to have Z-axis compensation so that it As the robot comes to its location, it doesn't know exactly when to stop. This allows you to have some cushion between the robot and the part position. It will compensate, and then also we have sensors here that will tell you if it's extended, retracted, or you can set a part presence as well. Now we can move back to our AGEU. This unit allows us to have compliance in all axes. So now we can rotate in any direction, swivel, we can compress. This will give you compliance in any direction you need. A good example for, or a good application for this would be bin picking, where you have random parts in a bin. The gripper would come down, robot would come down with the gripper and try to pick that, and then as it gripped, it might move in some unknown direction or random direction. So when this is locked, I'm going to go ahead and lock it now. You can see it pops back to the center. When it's unlocked, it's allowed to comply. Moving on to the third display, we can talk about the devices we have that are optional to help with different processes you might have on your robot. This is our DDF swivel unit. This is a slip ring feed through, and this allows a gripper to rotate endlessly on the end of arm tool. An application would be buffing, for instance, buffing the wheel, where the robot end effector would be going around and around continuously in loops, and you don't want to tangle up the wires and tubing. This allows you to go around and around without winding up any of the tubing, and it still passes through signal and air. So we can open and close the gripper, and you can also see with this green light that we're getting signal feed through at the same time. You can rotate right and left. There's a limitation to 120 RPMs with this. So we'll take a look at the application and see which one is right for you. This device is also, because this one has air and electric feed through, there may be times you don't need both. We offer optional units that have just electric in this case, or just air, which I don't have an example here, but we can fine tune the DDF to your needs. These two devices are collision sensors. These collision sensors would help protect you in the event of a collision. The difference between the two is that one is a manual reset and one is an automatic reset. One has a little more sensitivity than the other, and it has more freedom of movement. So for instance, we'll take a look at the OPS. OPS will trigger or allow collision to break away and then lock back. The unique thing about this is that it can move in any direction, it can even twist. So if you have a very expensive end of arm tool that is wide, for instance, in applications where you're doing plastic injection molding and the end of arm tool is very wide and delicate, this might be a good choice for you, because in the event of a collision, it would break away and swivel and get out of your way. Just keep in mind that with this particular unit, you do need to go back into the safety cage and reset it manually. For those applications that aren't quite as sensitive, but you need to have some protection, we have the OPR. OPR has the same breakaway feature. It can move in any direction, but it cannot twist, only in a few degrees of rotation. So this has a little more rigidity. The benefit of this is that an operator is not required to go back into the work cell and reset the unit. It will reset automatically and you can go back to work. So that's what we have today for robot accessories. I appreciate you tuning in and watching our channel. If you have any questions, please send those in and I'll be glad to answer those. Thank you.